been lied to.
Oh, absolutely.
I mean, for decades, the mainstream vision of our future in the stars has been fed to you as this comforting, frictionless glide. You picture sleek, silver corridors, artificial gravity humming quietly in the background, and ships that just slip through the void like luxury liners.
Right, the whole space magic aesthetic.
Exactly. But if you actually stare at the mathematical blueprints of a multiplanetary future, the real raw physics of it, that comforting lie just evaporates. Space travel isn't some magical aerodynamic dance. It is a brutal, inevitable war against the fundamental laws of nature.
It was a war of attrition. And look, the laws of physics do not take prisoners. When you look at the real underlying engineering required to actually conquer the solar system, when you strip away the cinematic gloss, you're looking at a clinical, almost paranoid reality.
Yeah, paranoid is the right word.
To build a future in the deep black, we have to rely on engines so phenomenally powerful they are practically sustained nuclear weapons strapped to the bottom of a metal tube. We're talking about the torch drive.
And what fascinates me is that our best roadmap for this, it doesn't come from a NASA press release. It comes from the visceral, unvarnished physics modeled in hard science fiction. Like, when we look at the engineering of the Epstein Drive or the ring gates or the physical mutation of the belters, we aren't just looking at space opera tropes.
No, we're looking at a terrifyingly accurate engineering manual.
Right. It's a window into the actual realities of what happens when human beings try to permanently occupy a vacuum. Because to escape the gravity well of Earth, we have to subject ourselves to mechanical, thermal, and biological horrors that will permanently alter what it means to be human.
And the terror really begins with a mathematical trap, a physical prison that has kept humanity locked on the surface of this rock since the dawn of our species.
The Rocket Equation.
Exactly. The architectural blueprint of this prison was first sketched out in 1903 by a Russian schoolteacher named Konstantin Tsiolkovsky. It's known as the Tsiolkovsky Rocket Equation. But, I mean, it shouldn't just be thought of as a formula on a chalkboard. It is a tyrant.
How so? Like, break down why it's a tyrant.
Well, it dictates an exponentially brutal reality. To move mass, you need fuel. But fuel is mass.
Which means you need more fuel to move the fuel you just added to move your payload.
Yes. It's this maddening compounding loop of dead weight. You add a gallon of fuel, but now your ship is heavier, so that gallon is slightly less effective than the last one.
It's like you're constantly paying a tax just to carry your own gas tank.
That's a great way to put it. The equation exposes the inherently unforgiving relationship between a rocket's change in velocity, what engineers call delta V, and the mass of the propellant required to achieve that change. Because as a rocket burns fuel to accelerate, its total mass decreases, right?
Right.
So the remaining propellant must accelerate both your payload and the unburned fuel still sitting in the tanks. Because of the logarithmic nature of this equation, achieving higher speeds doesn't just require more fuel, it requires disproportionately exponentially more fuel. You're caught in a cycle of diminishing returns.
So let's ground this in the hardware we actually use right now. Today, we rely heavily on chemical rockets. Burning liquid oxygen and liquid hydrogen.
Yeah, like the engines that power the space shuttle or the Artemis missions.
Right. So what is the absolute physical ceiling of that chemistry? Like, why can't we just build a bigger chemical rocket to go to Jupiter?
Because you run into the fundamental limits of the chemical bond itself. The physical speed limit of chemical exhaust is about 4.5 kilometers per second.
Wait, there's a literal speed limit?
Yes. That is a hard boundary set by the chemical energy density of the fuel. You cannot extract more kinetic energy from a chemical bond than naturally exists in that bond. The enthalpy of formation, the energy released when hydrogen and oxygen combine to form water, is a fixed number in the universe.
Okay, so 4.5 kilometers per second.
Right. But to just reach low Earth orbit, a spacecraft requires a delta A of approximately 9.4 kilometers per second.
Hold on. So we need our ship to go more than twice as fast as the literal fire coming out of the back of its own engines.
Oh.
That sounds physically impossible. How do you push a ship faster than its own exhaust?
You do it by throwing away almost the entire ship. The rocket equation dictates that to achieve a 9.4 kilometer per second velocity change with fuel that only moves at 4.5 kilometers per second, a single-stage rocket must be at least 88.4% propellant by mass.
Let that sink in for a moment. 88.4%.
Yeah, it's staggering.
It exposes the sheer insanity of our current aerospace design. I mean, We are basically building massive, towering skyscrapers made of ultra-thin metal, filling them to the brim with highly explosive chemicals, strapping a tiny metal chair to the very tip, and lighting the bottom on fire.
It's an engineering marvel, but you're right, it's also a deeply unhinged way to travel.
The overwhelming majority of the ship is just explosive dead weight. We leave, 11.6% for the structural tanks, the engines, the computers, and the actual human beings inside.
Barely even that, once you factor in the payload fairings.
How can we possibly hope to colonize a solar system, to move millions of tons of steel, water, and human infrastructure when almost everything we launch is just fuel required to carry itself?
You can't. Not with chemistry. I mean, chemical propulsion is sufficient to dip our toes into the cosmic ocean, but it cannot facilitate a true multiplanetary economy. The mass ratio requirements are simply too absurd.
Like, how absurd?
If you try to calculate a constant thrust mission to Jupiter using chemical rockets, the mass ratio requirement is a number so staggeringly huge, it is larger than the mass of the observable universe.
Oh, wow. So chemistry is literally a dead end for deep space.
Completely. To break this cycle, to actually escape the tyranny of the rocket equation, we have to stop relying on the breaking of chemical bonds. We have to start burning stars.
Which brings us to the theoretical leap required to actually live in the deep black, the torch drive. Now, in sci-fi, they call it the Epstein Drive, this magical, super efficient fusion engine that opens up the solar system. But if we pull that out of fiction and look at the real-world physics, we are talking about a direct fusion drive. Tell me what happens when we leave chemistry behind and step into nuclear fire.
A direct fusion drive, or DFD, represents a massive paradigm shift in how we conceive of propulsion. We aren't just burning fuel anymore. We are creating a sustained thermonuclear reaction. To understand this, you have to look at the mechanics of containing a fusion reaction in space. You are essentially trying to trap a miniature star.
Okay, trap a star. How?
We do this through something called a field reverse configuration reactor.
Wait, back up. A magnetic field holding a star. If I put a magnet near a campfire, nothing happens. The fire doesn't care. Why does a magnetic field work on a fusion reaction but not normal fire?
That is a crucial distinction. A normal campfire is a chemical reaction occurring in a gas. The atoms are neutral. Magnets only affect things with an electromagnetic charge.
Right.
But fusion doesn't happen in a gas. It happens in a plasma. When you heat matter to millions of degrees, the electrons are violently ripped away from the atomic nuclei. You're left with a chaotic soup of positively charged ions and negatively charged electrons.
And because they're charged.
Because they are charged, they are suddenly slaves to electromagnetism. If you create a powerful enough magnetic cage, you can force that plasma to hold a shape.
Okay, so the plasma is trapped in a magnetic cage. But Earth-bound experimental fusion reactors like tokamaks, they use these massive, multi-ton, super-cooled electromagnetic coils. You can't put a building-sized magnet on a spaceship and expect it to fly.
Which is why the field reverse configuration is so vital. It doesn't rely on massive external coils to do all the heavy lifting. Instead, it uses a rotating magnetic field to induce currents within the plasma itself.
The plasma becomes its own magnet.
Exactly. The plasma generates its own magnetic field, which pushes back against the external one, creating a self-contained, donut-shaped plasma torus. And the specific breakthrough required here is the use of an odd parity rotating magnetic field.
I hear the word parity and I think of math. What does odd parity mean in the context of holding a star inside a ship?
Think of magnetic field lines, like invisible rubber bands. In a fusion reactor, you want those rubber bands to form closed loops.
Right, to keep the plasma inside.
Yes, because if they break open and touch the walls of the reactor, the highly energetic plasma particles will follow those lines, bleed out, and your star dies. Or worse, it melts your ship.
Yikes.
When you apply an even parity rotating magnetic field, the geometry of the field forces those lines to open up. It creates a leak.
So even parity is like a punctured tire.
Precisely. But applying an odd parity magnetic field fundamentally changes the geometry. It maintains closed magnetic field lines. It folds the plasma back in on itself, tying the rubber bands into a tight, inescapable knot.
So it locks the star in place.
Yes. It stabilizes the plasma torus, allowing for 5 to 10-fold increase in electron temperature and massive improvements in energy confinement. This allows you to build a reactor that is small enough and light enough to actually strap to the back of a spacecraft.
But there is a horrifying catch to fusion that most people don't realize. When we talk about fusion today, we usually talk about deuterium-tritium fusion, right?
Right, DT fusion. It's the most common approach because it's the easiest to ignite.
But if we use traditional DT fusion in a torch drive, we're basically building a suicide machine for the crew.
We are. Deuterium-tritium fusion requires temperatures of roughly 150 million degrees Celsius. But it comes with a fatal flaw for spaceflight. 80% of the energy produced by a DT reaction is released in the form of high-energy, uncharged neutrons.
Uncharged, that's the terrifying word there, right? Because we just established that our entire containment system relies on magnets gripping charged particles.
Yes. Because they have no electric charge, neutrons are completely invisible to magnetic fields. They cannot be steered, trapped, or directed. They just fly outward in every direction at a massive fraction of the speed of light.
So they just ignore the magnetic nozzle.
Completely. If you try to use DT fusion in a torch drive, those neutrons will simply pass right through your magnetic cage. They will smash into the physical structural components of the engine in the ship.
Like billions of microscopic, unstoppable bullets.
Worse than bullets. Because when a high-energy neutron strikes the nucleus of an atom in your hull, it causes catastrophic radiation damage, literally knocking atoms out of their crystal lattice structure. But more importantly, it deposits its kinetic energy as pure heat directly into the metal.
So the ship would just absorb the heat of the star.
The ship would absorb 80% of the energy of a miniature sun. It would melt itself from the inside out in a matter of seconds.
So traditional fusion is a death sentence. It's a dirty fire. To survive, we need a clean fire. We need what is called an aneutron reaction.
Aneutron fuels are the absolute prerequisite for a torch drive. The two most prominent candidates are the fusion of deuterium and helium-3, or the fusion of a proton and boron-11.
And why are those better?
Because these reactions are profoundly different. They release almost all of their energy, over 99.9% in the case of proton-boron-11, in the form of charged particles, like alpha particles.
And because they have a charge, your magnetic fields can equally grip them.
Yes, you can use a magnetic nozzle to direct these highly energetic particles out the back of the ship. You convert the fusion energy directly into thrust, and the beauty of it is that the heat leaves with the exhaust plume. You aren't absorbing it into the ship.
But the universe never gives you something for nothing, does it? The catch with proton-boron-11, this holy grail of clean, direct thrust fusion, is the ignition temperature.
Oh, it's a massive hurdle.
We said DT fusion takes 150 million degrees. To get a proton and boron-11 to overcome their electrostatic repulsion and actually fuse, you need to heat the plasma to 1.5 billion degrees Celsius.
1.5 billion. It is an almost incomprehensible number. It is nearly 100 times hotter than the core of our own sun.
Let's stop and look at the sheer scale of what we're building here. We've trapped a miniature, superheated sun running at 1.5 billion degrees inside a magnetic bottle of closed odd parity field lines. And we're shooting the charged exhaust out the back. Let's talk about the awe-striking numbers this produces, because this is where the physics start to look frighteningly real.
The efficiency of an engine is measured by its specific impulse and its exhaust velocity. Remember, a chemical rocket maxes out at an exhaust velocity of 4.5 kilometers per second.
Right.
A mature, high-performance fusion torch drive achieves an exhaust velocity of 11,000 kilometers per second.
That is roughly 3.7% the speed of light coming out of the tailpipe.
It fundamentally rewrites the architecture of the solar system. With that kind of efficiency, you aren't coasting on Hohmann transfer orbits for years, waiting for planets to align. You can maintain a constant, steady thrust for the entire journey.
So you just point it where you want to go and hit the gas.
Exactly. A trip to Jupiter, which currently takes our probes the better part of a decade, is reduced to a casual 5.7-day sprint. You accelerate at 1 g halfway there, flip the ship around, and decelerate at 1 g the rest of the way.
It shrinks the solar system into a neighborhood, but listening to this, 1.5 billion degrees, 11,000 kilometers per second exhaust. We've escaped the mass trap of the rocket equation, but haven't we just strapped human beings to the front of a continuously detonating thermonuclear bomb?
We have. And that realization brings us face to face with the second great prison of space exploration. Escaping the tyranny of the rocket equation lands humanity squarely in an even more inescapable, merciless trap. Thermodynamic.
The heat trap.
The heat trap. If a torch drive is producing the kind of thrust necessary to move a massive ship across the solar system in days, it is generating phenomenal amounts of power. To push a multi-thousand-ton vessel at 1 g continuous acceleration, we are talking about engine power on the scale of 100 terawatts.
Just to contextualize that for you listening, 100 terawatts is roughly 5 times the entire global energy consumption of Earth right now. 5 Earths worth of power generation contained inside one ship.
And here is where thermodynamics becomes your executioner. No engine, absolutely no machine in the universe, is 100% efficient. Some fraction of that energy will inevitably bleed into the ship as waste heat.
But wait, we just solved the neutron problem. We said the proton boron 11 fuel chutes charge particles out the back, taking the heat with them. Where is this waste heat coming from?
Even with an incredibly efficient magnetic nozzle directing the plasma, you still have heat soaking into the hull through radiation emitted by the plasma itself. Specifically something called Bremsstrahlung radiation.
Bremsstrahlung? That sounds German.
It is. It translates to braking radiation. Inside that 1.5 billion degree plasma, you have electrons moving at relativistic speeds. Whenever an electron passes close to an atomic nucleus, the electromagnetic force of the nucleus pulls on it, causing the electron to violently swerve and slow down.
Like hitting the brakes.
Exactly. And because energy must be conserved, the kinetic energy the electron loses in that swerve is instantly emitted as a high-energy X-ray photon.
And X-rays don't care about your magnetic fields either.
Not at all. They shine outward like a light bulb, striking the physical walls of the reactor and the ship, converting their energy into pure heat. Let's say your engine is a miraculous 99% efficient.
Okay.
That means 1% of 100 terawatts, 1 terawatt of pure heat, is dumping directly into the physical structure of your spacecraft every single second.
And on Earth, if something gets too hot, we have air, we have water, we have conduction and convection to carry the heat away. The atmosphere acts as a giant thermal sponge. If a nuclear reactor gets hot, we pump ocean water through it. But in the vacuum of space,
there is no air, there is no water. Space is a perfect vacuum, which makes it a perfect insulator. Heat cannot leave your ship through conduction or convection.
So you're just trapped in a thermos.
Exactly. If you put a hot cup of coffee in a vacuum flask, it stays hot for hours. The only way heat can escape a spaceship into the void is through thermal radiation. And thermal radiation is governed by the ruthless mathematics of the Stefan Boltzmann law.
Break that law down for us mechanically, because this is the exact reason why the ships we imagine in movie are physically impossible.
The Stefan Boltzmann law dictates that the amount of heat an object can radiate away is proportional to the surface area of the radiator, multiplied by the 4th power of its absolute temperature.
Which basically says you need surface area. A lot of it.
Exactly. Your ability to radiate heat scales with surface area. To radiate away 1 terawatt of waste heat, you need an unfathomable amount of square footage. If you tried to use solid metal radiator panels like the ones you see sticking out of the International Space Station, they would either melt instantly from the thermal load, or they would have to be so massive and so heavy that you're right back in the prison of the rocket equation.
You'd be hauling around thousands of tons of dead metal just to keep from cooking yourself.
Right. It defeats the entire purpose of the torch drive.
So solid metal is completely out. The ship is producing too much heat. If it keeps that heat, the internal temperature spikes, the crew boils alive inside their own hull, and the metal of the ship literally vaporizes. How does the ship survive?
It has to bleed.
Bleed.
To survive the heat trap, the ship must utilize something called a liquid droplet radiator, or LDR. Instead of solid panels, the ship pumps its waste heat into a working fluid, typically a liquid metal with a low vapor pressure, meaning it won't instantly boil away in a vacuum. We're looking at substances like liquid tin, liquid lithium, or even liquid bromine.
Liquid tin, just circulating through the walls.
Yeah. The ship uses an electromagnetic pump to push this superheated liquid metal to the exterior of the hull. There, a generator sprays a continuous, massive mist of this fluid directly out into the hard vacuum of space.
Out into the open void.
Yes. We are talking about streams of millions of microscopic droplets, each only 50 to 100 micrometers in diameter. That's about the width of a human hair. These droplets fan out into a massive glowing sheet alongside the ship, exposing an enormous collective surface area to the cold of space.
It's an unbelievable visual. You have to imagine it. The ship is screaming through the void of the solar system, and trailing beside it are these massive angelic wings of glowing red, atomized liquid metal suspended in the vacuum. It looks beautiful, but it's a mechanism of sheer desperation.
The physics of it are staggering. Because the droplets are so microscopic, their surface area to volume ratio is incredibly high. They radiate their heat incredibly fast. A 100 micrometer droplet of liquid tin will drop from 500 Kelvin down to 252 Kelvin in just 2 seconds.
2 seconds to freeze.
Right. And once they've dumped their heat into the dark, they travel down the length of the ship and are caught by a centrifugal collector mechanism. They're gathered back up, pumped back inside to absorb more reactor heat, and sprayed out again. It is a continuous, recirculating cardiovascular system of liquid metal.
To survive the vacuum, the ship has to constantly sweat glowing liquid metal. But here is the thought that terrifies me. We are talking about a fragile mist of fluid hovering completely unattached outside the ship, traveling at immense speeds. What happens if the ship suddenly has to change direction? Say there's a micrometeoroid, or it's a military vessel executing an evasive maneuver.
That is the razor's edge the crew dances on every single second. The droplets are in free fall alongside the ship. They possess their own inertia. If the pilot executes a lateral maneuver of just a tiny fraction of a G, even a thousandth of a G, the solid ship moves, but the unattached droplet stream does not.
The ship simply slides right out from under its own radiators.
Yes. The glowing mist scatters into the infinite void.
You lose your coolant.
You lose your coolant instantly. And with a 100 terawatt engine burning at your back, without that radiator stream to dump the heat, the temperature builds up catastrophically. The ship is instantly defenseless against its own thermal output.
How much time would they have?
Within moments, the internal temperature spikes, the structural integrity of the magnetic containment fails, the fusion reaction breaches, and the ship vaporizes itself. You are perfectly trapped between freezing in the dark if the reactor fails and vaporizing in an instant if your sweat gets blown away.
So if we solve the heat problem, right, if we manage to keep the radiators perfectly aligned and the torch drive burning, we still have a massive variable we haven't accounted for, us.
The biology.
Exactly. We're engineering these ships to survive the vacuum, but we're completely ignoring the fact that our biology relies on the Earth pulling us down at 9.8 meters per second squared. We are forcing human biology into a machine environment that is deeply hostile to our existence. What actually happens to a human body when you put it in this environment?
The biological cost of the torch drive is where the reality of space colonization becomes truly tragic. This is where the belter physiology we see in hard sci-fi is incredibly accurate. We touched on the idea of the constant 1G thrust earlier. The engine burns continuously, accelerating the ship at 9.8 meters per second squared.
Which creates the illusion of gravity. There is no magical gravity plating on the floor.
No. The floor simply accelerates upward into your feet at the exact same rate Earth's surface pushes against you. As long as the engine is burning at 1G, your body feels weight, it feels normal.
Right.
But this highlights the fundamental fragility of the human form. We evolved over billions of years at the bottom of a 1G gravity well. Every single system in our body, our bones, our blood, our muscles, our eyes, is dynamically calibrated to fight Earth's gravity every second of every day.
And when you take that gravity away, say when the engine stops for a course correction, or more importantly, what happens to the millions of people who live on asteroid stations, or the working class populations who can't afford the immense fuel required for a continuous 1G burn and have to travel at a fraction of a G? Your body must begin to unravel.
It undergoes rapid systemic deconditioning. It's a tragedy of cellular efficiency, really. Your body is incredibly pragmatic. If it doesn't need to expend massive amounts of metabolic energy maintaining dense bone and heavy muscle to fight gravity, it simply stops doing it.
It just shuts down.
Clinical breakdown begins immediately. At the cellular level, your bones have a system called a mechanostat.
How does the bone even know if there's gravity or not? It doesn't have a brain.
It relies on electricity, specifically piezoelectric signals. The mineral crystals in your bone hydroxyapatite generate tiny electrical currents when they're physically compressed or bent. When you walk on Earth, the weight of gravity bends your bones on a microscopic level.
Oh, wow.
Those piezoelectric sparks are the signals that tell your osteoblast cells to build new bone.
And without gravity, the bone doesn't flex, the electrical signals go silent.
The mechanostat shuts off entirely. The osteoblasts stop building, but the cells that break down bone, the osteoclasts, just keep working. It's a demolition crew left completely unsupervised. In microgravity, human bone density evaporates at a rate of 1 to 2% per month.
Per month?
Yes. The calcium simply dissolves out of your skeleton into your bloodstream and is excreted through your kidneys, which, by the way, causes massive kidney stones.
It's horrifying.
Meanwhile, your muscles, no longer needed to maintain your posture against Earth's pull, begin to literally digest themselves. Muscle fibers can lose 30% of their volume in just 2 weeks.
It's accelerated aging, it's frailty on fast forward. But it's not just the bones and muscles. I remember reading about what happens to the cardiovascular system, and it is disturbing.
Yes. On Earth, gravity constantly pulls your blood and bodily fluids down into your legs. Your cardiovascular system, specifically your heart and the valves in your veins, is designed to pump incredibly hard to push that fluid back up to your brain.
So it's always fighting gravity.
Right. In zero gravity or low gravity, that upward pumping force suddenly has no resistance. So all the fluid in your body rushes violently up into your torso and your skull. It's called fluid shift.
You get this puffy, swollen moon face. Astronauts always look like they have a severe cold. But the real danger is what that fluid pressure does to the brain and the eyes.
It causes a severe condition known as spaceflight-associated neuroocular syndrome, or SANS. The fluid shift dramatically increases intracranial pressure. That cerebrospinal fluid literally has nowhere to go, so it pushes on the back of the eyes.
Oh, God.
It physically flattens the eyeballs from behind and causes the optic nerve to swell and buckle. It leads to severe visual disturbances and, over time, irreversible permanent vision loss.
And what about the blood itself?
Because your body senses it suddenly has too much fluid in the upper body, the kidneys signal to decrease blood volume. You stop producing red blood cells, you develop what is known as space anemia. The blood literally thins out.
So you have frail bones, atrophied muscles, failing vision, and thinned blood. And this is just what happens to highly trained, perfectly healthy adult astronauts who spend a few months in orbit.
Right, people who started at a baseline of 1G.
But the darkest implication of all this isn't what happens to an adult. It's what happens when we try to build a permanent, multi-planetary society. What happens to the children?
This is where the developmental biology becomes genuinely chilling. Mammalian reproduction and embryonic development are deeply sensitive to gravitational vectors. Current research into embryonic stem cells suggests that reproduction under levels of gravity lower than roughly 0.5 G may be fundamentally mechanically broken.
Why? What is happening to the cells as they try to divide?
Embryonic cells in low gravity face what researchers call anabolic resistance. When an embryo is trying to build the complex protein structures necessary for organ formation or for an architectural skeleton, it needs a vector of gravity to help orient and stimulate that cellular growth. It needs it down to know how to back up.
So it loses its sense of direction.
Exactly. In hypergravity centrifuge experiments with mice, pregnancy struggle and the offspring have severe postural, neurological, and coordination defects. In microgravity or fractional gravity like the 0.38 G of Mars or the negligible gravity of an asteroid, the human body may simply not know how to build a human properly.
Paint that picture for a second, because this is the true horror of becoming a spacefaring species. We are talking about an entirely new generation of human beings born in the void, a people shaped by the absence of Earth.
Yes.
If someone born and raised in the microgravity of an asteroid belt, enduring generations of anabolic resistance, deactivated mechanostats, and altered cardiovascular systems, were to ever travel back to Earth,
Their bodies would be crushed. If they tried to stand up under the blue sky of their ancestral home under the full crushing weight of 1G, their cardiovascular system would lack the musculature to pump blood to their brain against gravity. They would pass out immediately.
And their bones?
Their skeletons, demineralized and structurally altered from birth, would literally snap like glass under their own body weight.
We aren't just colonizing space. We are physically mutating ourselves to survive it. The torch drives get us there, but the environment fundamentally rewrites our biology. Which begs the question, what happens when this technological and evolutionary trajectory reaches its absolute logical endpoint? If our fusion drives and our biological unraveling are the peak of human engineering, what does the physics of an advanced alien paradigm look like?
When you look closely at advanced theoretical physics and speculative nanotechnology, you realize that the alien might not be little green men in flying saucers. The ultimate manifestation of an advanced civilization isn't biological at all. It is best understood as programmable matter.
Programmable matter. This brings us to the concept of the protomolecule.
Exactly.
Deconstruct this for us, because when you see the protomolecule in fiction, it looks like this glowing blue space magic, this infectious monster in the dark. But if you analyze the physics it represents, it is a highly specific, deeply terrifying manifestation of actual theoretical science.
The protomolecule represents the absolute endpoint of molecular nanotechnology. To understand it, you have to go back to 1959, when the physicist Richard Feynman gave a famous lecture titled, "There's Plenty of Room at the Bottom." He suggested that eventually humanity would be able to arrange atoms one by one, building complex submicroscopic machines out of individual molecules.
Right, molecular engineering.
Today, this field is moving out of theoretical physics and into reality through a discipline called claytronics.
Claytronics, like molding clay, but electronic.
Exactly. Researchers are currently developing Kadam's claytronic atoms. These are millimeter scale and eventually nanoscale, units that contain their own power source, communication ability, and computation. They can physically interact with one another to self-assemble into completely arbitrary 3D shapes.
And we are already seeing this transition from theory to reality right now. Material science is utilizing AI-driven design to create self-assembling smart materials, things that respond to heat and light, rearranging their crystal lattices, repairing themselves like living tissue.
Now take that concept and scale it up to an intelligence millions of years older than us. Programmable matter doesn't just fold itself into shapes. It can sense, compute, and actuate its own physical characteristics at the molecular level. It operates like a swarm of microscopic supercomputers.
Okay, but why is that so terrifying?
Because here is the visceral horror of that. When programmable matter encounters a human being, it doesn't see us as a living, breathing creature. It doesn't recognize our consciousness, our history, or our rights.
Because to a swarm of nanomachines, a human is just a very specific, disorganized arrangement of atoms. It just sees raw materials, it sees carbon, it sees calcium in our bones, it sees the iron in our blood.
Yes. It views our biological structure merely as available hardware. It is a biological machine hybrid executing a vast, uncaring mathematical equation, and our flesh is just the substrate it uses to run its code.
It just recycles us.
It dismantles humans at the atomic level, tearing the carbon and calcium apart and repurposing our biomass to build whatever complex non-human structures its programming demands. It is the ultimate violation because it turns the very atoms of your own body into the machinery of your destruction.
But the horror doesn't stop at dismantling biology. In the physics models of this kind of advanced matter, it bypasses our physical prisons entirely. It bypasses the rocket equation. It bypasses thermodynamics. How does it do that? How does a civilization move without a fusion torch drive, without bleeding, glowing liquid metal into the dark?
It does so by manipulating the fundamental forces of the universe at a dimensional level. To understand how programmable matter could move without rockets, we have to look at theoretical frameworks like Kaluza-Klein theory and Mach's principle.
Break down Mach's principle for me, because this fundamentally changes how we think about movement.
Ernst Mach was a physicist who heavily influenced Einstein. Mach's principle is a thought experiment about inertia, the resistance of an object to acceleration. Why is it hard to push a heavy rock? Mach suggested that inertia is not an intrinsic property of the rock itself.
What is it then?
He argued the rock's inertia is caused by its gravitational and physical interaction with all the other matter in the universe. The distant stars, the galaxies, everything is gravitationally connected.
So, if I push a rock on Earth, I am theoretically pushing against the gravitational field of the entire cosmos.
That is the implication. And if an advanced system of programmable matter can figure out how to artificially manipulate that interaction, if it can control how heavily it interacts with the universal gravitational field, it can generate thrust without fuel.
By pushing against the universe itself.
By fluctuating its internal mass while simultaneously pushing and pulling against the gravitational field of the universe itself, it effectively recycles propellant from the fabric of space-time. It creates a reactionless drive. It can move massive asteroids at incredible speeds without a single exhaust plume, breaking Newton's third law of motion as we understand it.
And it goes even deeper than that. To travel between star systems instantly, it isn't just manipulating gravity, it has to manipulate dimensions we can't even perceive.
Which brings us to brain cosmology and string theory. We spent all this time talking about moving through the 3D space of our solar system, but the mathematics of string theory require the universe to have 10 or 11 dimensions to function.
Right, but we, as humans, only experience 4. 3 spatial dimensions, up and down, left and right, forward and backward, and 1 dimension of time. This is always the part that breaks my brain. If there are 11 dimensions, where are the other 7? Why can't I look at them?
In theoretical physics, they are compactified. Imagine looking at a telephone wire from a mile away. It looks like a 1D line. But if you get close, you see an ant crawling around the circumference of the wire. The wire actually has a 2D surface, but from a distance, that dimension is curled up and invisible.
So the dimensions are just really, really small.
String theory suggests the extra dimensions of our universe are rolled up so tightly into incredibly complex submicroscopic geometric shapes called Calabi-Yau manifolds that our macroscopic biology simply cannot perceive them.
Okay, so the dimensions are folded up at the quantum level. But how does that allow for interstellar travel?
Because of brain cosmology. This theory suggests that our entire 3D observable universe is just a thin membrane, a brain floating in a vastly larger 10 or 11-dimensional space.
Imagine the universe as a flat sheet of paper. We live on the surface of the paper, restricted to walking left, right, forward, backward. But there is a 3D room the paper is floating in.
Exactly. That room is what theoretical physicists call the bulk. It is the higher dimensional space between universes. We are trapped on the 2D paper. But if an advanced civilization of programmable matter understands those Calabi-Yau manifolds, if it can unroll those higher dimensions, it can fold our 3D space.
You can create Einstein-Rosen bridges,
Yeah.
wormholes. So when we look at the concept of ring gates, these massive alien structures that allow for instantaneous interstellar travel, they aren't just doors. They act like a pencil punching a hole right through our sheet of paper into the room itself, allowing us to skip across the surface of the paper by stepping completely outside of it.
They are truncations of space-time. They are physical punctures in our 3D membrane. They slice through the tightly rolled dimensions, forcibly exposing our reality to the spaces between universes. They expose us to the bulk.
We've sliced open the fabric of our reality, and by doing that, we've invited something in from the outside. We thought we were mastering the universe, but we just opened a window in a dark forest, and now whatever lives in the room outside our piece of paper knows we are here.
And when we synthesize this entire journey, the toll it takes on humanity becomes blindingly clear. We began with a cold mathematical prison of the Tsiolkovsky Rocket Equation. We realized that to escape the massive chemical fuels, we had to build fusion torches that burn at 1.5 billion degrees, trading the prison of mass for the new, even deadlier prison of thermodynamics.
We forced our ships to bleed glowing liquid metal just to keep us from vaporizing in our own nuclear fire.
And we found that even if our incredible machines survive the heat trap, the human body does not. We subject our bones to dissolving, our muscles to atrophy, our eyes to crushing fluid pressure, and our children to fundamental developmental failure.
It's a complete physical breakdown.
And finally, when we look at the ultimate technological endpoint of this survival, we face the terrifying prospect of our very atoms being hijacked by programmable matter and our space-time being torn open to higher dimensional voids.
The entry fee for the solar system is our humanity. We're trapped between the crushing gravity and nuclear fire of our own engines and the terrifying prospect of being rewritten by the programmable math of a higher dimension.
Yeah.
We are stripping away pieces of ourselves, cell by cell, bone by bone, just to exist in the black.
The universe is vast, and the physics dictate that it is mathematically accessible, but it is deeply, fundamentally uncompromising to biology.
Which leaves you with one final thought. If we successfully conquer the thermodynamics, if we rewrite our genetics to withstand zero gravity, and if we learn to navigate the multidimensional physics of the bulk, we will have conquered the universe. But we will have done it by designing environments and bodies where a natural-born Earth human could no longer survive. We won't just be a different culture. We will be a fundamentally different species. And by the time we conquer the stars, Earth might become the one planet in the galaxy its own children can never visit.